Hello students, my name is Fizul Hlachwayo from Umgungundlovu TVET College. Today we are going to look at level 3 mathematics. Our topic today is space, shape and measurement. And our subject outcome is SO 3.3, which is using the Cartesian coordinate system to derive and apply equations. In this series of lessons, we are going to have 3 lessons. The first one, we are going to derive and apply the equation of a line through 2 given points. The second lesson is broken down into 2 parts. Lesson 2A, we will determine the equation of a line parallel to another line. In lesson 2B, we will determine the equation of a line perpendicular to another line. In the third part of this series of lessons, which is also broken down into 2, 3A will derive and use the angle of inclination of a line. And in lesson 3B, we are going to look at typical examination questions. In terms of the pre-knowledge, what do we bring from level 2? You will remember that at level 2, we had a similar topic of space, shape, and measurement. And so we need to remind ourselves about the Cartesian coordinate system, which is the x and the y axis. We also need to remind ourselves about the plotting of ordered number pairs or the plotting of points. I'm going to demonstrate that on the board. This will represent the x and the y axis. The horizontal axis is the x-axis, and the vertical axis, it is the y-axis. You will remember that these 2 number lines, they meet at the point of origin. The x-axis is positive to the right, and it is negative to the left. The y-axis is positive going up, and it is negative going down. And when we plot our points, we plot our points referencing on the number line. So a point like this one would be point -2, 3. That would be the point -2, 3. So when we indicate our points or our coordinates on the coordinate system, we identify them as the x component and the y component always. The third thing we need to remind ourselves, it is to calculate the distance d between 2 points using the formula that I've just shown you there. The fourth thing would be to calculate the gradient m of a line joining 2 points using the formula that I've just displayed there. The fifth thing we need to remind ourselves is to calculate the coordinates of the midpoint m of a line segment using the given formula. Now, let us look at today's lesson. As I said earlier on, we are going to look at determining the equation of a line between 2 points. The equation of a line can be derived from the gradient equation. So if we are given the following straight line graph, I have the point xy, which I have indicated in the middle. I also have another point, x1, y1. I have a third point, x2, y2. You can choose which point you want to call x1, y1, x2, y2. It will not make a big difference. Now, when we have got such a graph, the gradient is indicated at the top here. It will be the change in y divided by the change in x. And so we can get it by saying the value y2 minus the value y1 divided by the value x2 minus the value x1. That gives us m, the gradient. Using the same graph, we can get the gradient by saying the value y minus y1 or over x minus x1. So whichever pair of coordinates that you use on the straight line, they could be used to give you the gradient of that straight line. So now, when you've got these equations, whichever one that you want to use, we then rewrite the gradient equation in the form y is equal to mx plus c. And I want to talk a little bit about this equation. Now, the equation y is equal to mx plus c. This y is the y component of the coordinate, and the x, it is the x component of the coordinate. M, it is the gradient. And c, it is a constant. Or sometimes we also call it the y-intercept. So a graph represented by this equation will have this y as the y component of the coordinate, the x as the x component of the coordinate, and m will be the gradient of that graph, and then the c is the constant, which is also where that graph cuts the y-intercept. So continuing from where we stopped, from this gradient equation, we then rearrange in the form y is equal to mx plus c, and it becomes y minus y1 is equal to m in brackets x minus x1. This expression here, this equation here, is the general equation of a line between 2 points, where the x1 and y1 are the coordinates of any of the given points that you have on the straight line. Now we're going to look at 2 practice questions. The first question says, determine the equation of the line that goes through the points -2, 3, and 2 minus 5. Now, how do we deal with that? The first thing we need to do is to draw a sketch to guide us, but this is an optional step. I actually recommend my students to draw this sketch, because a sketch will always give you a better picture of what you are dealing with. It will tell you if you are off line or you are in line. So I will then go to the board and explain how we do this and how we find the solution. You can see here I have the Cartesian plane. So the first thing we have is a point -2, 3. And like I said, this is the x-axis, so this is -1, -2. This is 1, 2, 3. This is 1, 2, 3. -1, -4, -5. So the point -2, 3 will be -2, 3. -2, 3. So we'll have a point there, and we'll call that -2, 3. -2 from the x-axis and 3 from the y-axis. The second point, it is 2 minus 5. This is 2 from the x-axis, and then this is 5 minus 5 from the y-axis. That becomes 2 minus 5. So the purpose of drawing this is that we can see clearly how the graph is positioned on the Cartesian coordinate. I will then make a quick straight line going down there. The next thing then is to allocate these 2 points. Which one is x1, y1, and which one is x2, y2? You can call this x1, y1, and this one x2, y2. You can also call, if you want, this one x1, y1, and this one x2, y2. It doesn't make a big difference. For now, I'll call this x1, y1, and this will be x2, y2. Therefore, the gradient equation M, we said it is y2 minus y1 over x2 minus x1. Our y2, it is minus 5. Minus y1 is 3, divided by x2, which is 2, minus x1, which is minus 2. We need to be very careful at this stage, because this minus sign comes with the formula, but this x coordinate comes with its negative. So we need to record both because those signs will change. This gives us minus 8 over 4, and our gradient is minus 2. When we have done this, then we take this gradient and introduce it in the general formula. Y minus y1 is mx minus x1. This becomes y minus our y1, it is 3, is equal to m, our gradient is minus 2, the one that we've just calculated here, multiplied by x minus our x1, again, it is minus 2. This becomes y minus 3 is minus 2x. Two negatives become a positive. Minus 2 times 2 becomes minus 4. Therefore, y is minus 2x minus 1. This becomes the equation of this line. You can see that it's written in the form y is equal to mx plus or minus c. Minus 2, which is the value of m, is our gradient, and minus 1 is the constant, or where the graph cuts the y-axis. That's where, again, your sketch graph will confirm that what you have done makes sense and is correct. You can see that roughly my graph should be cutting at minus 1. Of course, it is a sketch, but it gives you a clear indication that that should make sense, that should agree with this graph. In example 2, we are going to determine the equation of the line joining the intersection of two equations. The first equation is y is equal to x plus 3, and the second equation is y is equal to minus 2x plus 6. And then the line whose equation we want to find starts from the intersection of these two equations, and then it cuts the x-axis at point 5. Once again, we can draw a sketch which will guide us on how this situation is panning out. Our first equation, as we have indicated, is y is equal to x plus 3. Using the intercept method, which is the quickest way when we want to sketch a graph. And we say when x is equal to 0, obviously our y is going to be a 3. So the coordinate becomes 0, 3, when x is 0. And when y is 0, our x is going to be minus 3. And the point will be minus 3, 0. So we can then indicate these two coordinates on the Cartesian plane, join them to draw the straight line representing this equation. So we've got 0, 3, and minus 3, 0. So our graph roughly will be like that. Y is equal to x plus 3. Then the second equation, y is equal to minus 2x plus 6. We again use the intercept method to identify the 2 points where this graph cuts the x and the y-axis. Again, when x is 0, it means our y is going to be 6. So the coordinate is going to be 0, 6. And when y is 0, our x will bring the 2, it becomes positive. Our x is going to be 3. So the coordinate becomes 3, 0. This intercept method of sketching graphs, we bring it from level 2. Therefore, our new coordinates for the new line will be 0, 6, and 3, 0. So our graph will be roughly like that. And we'll call this graph y is equal to minus 2x plus 6. So the question says we need to find the equation of a straight line, which starts from the point of intersection, which is that point. This line starts here, and it will cut the x-axis at point number 5. So I'll use a dotted line to represent that. Right. So this new line starts there and ends there. We need to find the equation of this line. But using the sketch, it is not going to be easy to know the coordinates of this position. So we need to use a calculation to determine the exact coordinates. We cannot read them from the sketch because it is a sketch. Our two equations, y is equal to x plus 3 and y is equal to minus 2x plus 6. This y and this y, they are the same, which means this right-hand side of the equation is equal to this right-hand side of the equation. So we can equate these two to determine the x component, which means x plus 3 is equal to minus 2x plus 6. If we bring the 2x this side, it becomes x plus 2x is equal to, we keep the 6, we bring the 3, it becomes negative. 3x is equal to 3, therefore x is equal to 1. So we now know that our x value should be 1. And I think roughly from our sketch, it should agree. Then we use this 1 value and substitute it in any one of the two equations to determine the y component. I will use the first equation, y is equal to x plus 3. Now we know that x is 1. Therefore, y is equal to 1 plus 3, which is 4. So our x is 1 and our y is 4. The coordinate is 1, 4. And again, the advantage of drawing a sketch, you can see that roughly it would agree that it is 1, 4. So we now have the coordinate 1, 4 for the point of intersection. This point, it is cutting the graph is cutting the x-axis at 5. Therefore, this coordinate will be 5, 0. So we now have two coordinates, clearly. So what we need to do now is to use those two coordinates of this new line to find the gradient of this line. Gradient, which is m, is y2 minus y1 over x2 minus x1. Once again, I'll call this point 1, 4, I'll call it x1, y1, and this one x2, y2. Like I said earlier on, it's your choice. You can call this x2, y2, and this one x1, y1. It doesn't make a difference. y2 is 0 minus y1, it is 4, divided by x2 is 5 minus x1, it is 1. Therefore, 0 minus 4 is minus 4 over 4. The gradient is minus 1. Then we go to substitute this gradient now in our general equation, which is y minus y1 is equal to mx minus x1. Y minus, or y1 is 4, so y minus 4 is equal to m, which is minus 1, in brackets, x minus our x1 is 1. Y minus 4 is equal to minus x, negative and negative, it becomes a positive. Then y is equal to minus x, and then it becomes plus 5. So that becomes the equation of the new line. Again, you can see that there is a negative coefficient there, which is the minus 1, which is the gradient, and it agrees with a line slanting downwards. So that becomes the equation of the line that starts from the point of intersection to point number 5. In this lesson, therefore, we have learned the following. We have used the Cartesian coordinate system to derive and apply the equation of a line through two given points. We derived the equation of a line from the gradient equation. And we have also seen that it is helpful to sketch a graph from the given information, as that sketch will serve as a guide in solving the problem. It will give you a picture of what you are dealing with. In our next lesson, we will use the same Cartesian coordinate system to derive and apply the equation of a line parallel to another line, as well as a line perpendicular to another line. Okay, students, just as we wrap up this lesson, I thought we should just do one activity or one question as we make a conclusion for this lesson, which I have on the board. The question says, determine the equation of a line through 3, 4, or through the point 3, 4, and the origin. So this question, I like it because it doesn't give us clearly the two coordinates. In other words, it is challenging us to see if we know the origin. Therefore, I'm going to give you just 2 minutes to deal with this nice small question, then I'll come back to you. I hope and trust that you found it very easy to deal with. Now let's quickly go through it and see how we could have managed to find the equation of this line. Like I said earlier on, a sketch would be a good starting point because it will guide us on what we are dealing with. Therefore, this will be our sketch. So that will be our 4, that will be our 3, and therefore the point 3, 4 will be that one. And this line will cross the origin, which is where those two number lines meet. And therefore, I will draw my straight line, and we know that the origin, the coordinates is 0, 0. So now we've got our two coordinates. We then quickly get into the calculation of the gradient. I'll call this x1, y1. This will be x2, y2. Our gradient is y2 minus y1 over x2 minus x1. Our y2 is 4 minus 0. Our x2, it is 3, again, minus 0. So that gives us 4 over 3 is our gradient. It may not be necessary for you to convert this into a decimal. It is fine to leave it like that. And the next thing now is to substitute this gradient into the general equation, which is y minus y1 is equal to mx minus x1. Minus y1, it is 0, is equal to m, which is 4 over 3, x minus our x1 is 0 also. Therefore, it becomes y is equal to And that becomes the equation of the line. Something very interesting here is that we don't see a coordinate or an intercept there. Why? Because it is cutting the y-axis at 0. So we would not necessarily put plus 0 there. We'll just leave it as y is equal to 4 over 3x, because it cuts the y-axis at point 0. So we can always ignore this part. My students, have a wonderful day until we meet again.